So I was intended to be an orator again, but then I changed my mind. So that's what they're fighting me. And I'm way more comfortable talking about data anyway, and I just felt compelled that I wanted to share this with you. So this is what we've learned. What I want to try to do within like 2 minutes is give you a synopsis of what I and some of my colleagues have learned after 10 or 15 years of work in the Florida aquifer. Okay, so this is a map that shows data. This is not models that I talked about before. This is dye tracing data that is basically showing you how the water flows through this portion of the Florida aquifer. The yellow circles are places that we injected dye, and then the red lines are an inferred linear path from where we injected it to where we detected it. And then in the table over there, I'm going to show you, I've listed out how far it went, how fast it traveled, and how long it took to get there, right? So first thing, what I hope everybody sees, is that we've injected dye all over the basin, and the water always flowed to Ocala Springs, okay? So it flows to Ocala Springs. I'm just going to walk you through this. The places really aren't so important, but Fisher Creek to Ocala Springs, 11 miles, 1 mile per day, it took a week. Black Creek to Ocala Springs, 11 miles, a mile per day, it took a week. Ames Sink to Ocala Springs. Ames Sink is basically receiving a large portion of the city of Tallahassee's surface water runoff. Ames Sink to Ocala Springs, 6 miles, it traveled at ½ a mile per day, it takes about 2 weeks. The spray field, which is the fate of treated wastewater from the city of Tallahassee, is about 10 miles. It traveled 10 miles to Ocala Springs, traveled about 1,000 feet per day, and it took 2 months. Lost Creek to Ocala Springs, it's 7.5 miles. It's more than Lost Creek to Spring Creek, 7.5 miles, faster than a mile per day. It took about a week. Lost Creek also flows to Ocala Springs, about the same distance, about 500 feet per day. It took 2 months. Bird Sink, which is the northernmost point, way up above the scarp of the confining unit. Bird Sink to St. Mark's River Rise, 15.5 miles, faster than a mile per day. It took 2 weeks. Bird Sink, water from Bird Sink also showed up at Ocala Springs, 23 miles away, ½ a mile per day. It took 1.5 months. So the reason I really wanted to show you this is that groundwater through the Florida aquifer does not, in fact, travel very slowly. It travels very quickly. Okay, now, one of the things that you could look at is, first you think, no, this is not possible, then you demonstrate that it's possible, then you say, oh, well, this is just a postage stamp. This is somehow unique to Ocala. It doesn't happen anywhere else. If I had more time, I would show you similar tracer tests that have been done in the Santa Fe River Basin that have about the same types of velocities over the same types of distances. We've done traces have been done here to Silver Springs, showing about the same types of velocities. And even you could go all the way to Miami and look at tracer tests that were done in Dade County that came up with, again, shockingly high velocities. And that one, I really love that one. So I always love to talk about it. Google the pink underwear test. Everybody will remember that. The pink underwear test. And you'll see that it's not a postage stamp, it's not unique. Groundwater travels very quickly. Implications for groundwater quality, in my opinion, are very profound, right? Because it means that the time at which it's going to take for water that gets into the aquifer to get to springs and affect the water quality there is not very long, okay? Like, for instance, the spray field, it's only a couple of months before it's starting to affect the water quality of Ocala Springs. The good news is that if you engage in protective measures, if you engage in reduction of those issues, we should be able to expect to see changes on a relatively short period of time. Now, it's not going to be as fast as this on the recovery for reasons that I don't have time to show, but the point is that within our lifetimes we can see very dramatic improvements if we engage in these types of activities that everybody's been talking about today. Okay, so how does this work? This is also what we learned again from Ocala Springs. Groundwater is flowing through the system, and it's flowing into these conduits. The conduits are receiving groundwater from the aquifer around it, and then it conveys it very quickly out to the springs. At Ocala, and many of the springs in... I didn't even touch it. At Ocala and many of the other springs in Florida, we know that we have surface water that enters the ground through swalettes or sinkholes. That goes into conduits, it mixes with the water that's being captured from the aquifer, and then you end up with a mixture of those two waters discharging at the springs. That's why we have these dark water and clear water days at Ocala. Can I advance it? Can you advance a slide for me? When the rivers dry up, or when you move into a drought period, you don't get any of that water flowing into the swalettes, the springs get clear, right? Because you don't have as much groundwater going into the system. Can you go to the next slide? All right, so what happens if we add wells to this equation? If we add wells to this equation, what we're doing is capturing water. That's what we do. For years and years, we were very proud as hydrogeologists of being able to show people how to capture water from its otherwise natural discharge. That's what we do. Wells capture water. They take the water that would otherwise go to those conduits and get out to the springs, and they divert it to the wells. That's how it goes. It's a pretty simple mass balance equation. Now what we do, a lot of the things that we do in terms of management strategies, we focus on the degree to which water levels are reduced. And one of the things that I want to point out is that we should be focusing on the capture. So by simply changing the question, I think we can all come to a much quicker, productive discussion about how to solve the problems, right? We want to know how much capture is taking place. As it turns out, that's going to come out to be about the same as pump. Can you go to the next slide? Go to the next one. This is a map of Springsheds. Okay, so my team and I worked for a little while on developing this map from data. All of those black lines are basically the capture zones for the springs in the central part of the peninsula, including, that's not Spring Creek, that's Silver Springs that in the middle there. But what I want to show you is that all of those are the capture zones. When you put those together, what it's showing is there's very little of the state that's left, right? All the springs are capturing all the water. So that means that when we take water out, we're affecting that spring water discharge. So again, as we go to quality, what we're able to show is that we can actually now, we can build models that show all this stuff. And when we do that, what we've seen is that vulnerability is predicated more on the proximity to these conduits than it is on the proximity to the feature itself. Like for instance, how far away something is from a spring doesn't necessarily mean that it's gonna, if it's a long way away, it doesn't mean that the spring is insulated from that activity, right? We have to understand how this water flows through the system to get a better handle on those vulnerabilities. The last point that I want to make is I've had a great opportunity to work with Jake Barn on the legislation of this Florida Springs bill and have some input with him and discussions. And one of the things that he keeps pointing out to me is that, and what Sean just said, is we spent roughly $250 million to see that water quality improvement at Ocala Springs. That's basically for something like 20 million gallons a day for a population of something like, for the population of Tallahassee. If you do the math and extrapolate it to the population of Florida, you can see that we have $1 trillion problem to deal with. So it's not possible, but it means that we have to really become more aggressive about how we discuss these things.